Hello students. So this is a question from NET December 2024 and it is actually based on motion of charged particle in electric and magnetic field. And just see the question. An electron enters a region of uniform electric and magnetic fields E naught and B naught. Its velocity E naught and B naught are mutually perpendicular. All of the three are perpendicular to each other. Initially, E naught is so adjusted that the electron suffers no deflection. It means net force is zero. E naught is then switched off and the electrons move in a circular path of radius r. The speed of electron and its charge to mass ratio would be. Okay, so first of all, let us apply this that there is no deflection. So that means Q into E naught will be equal to Q into V cross B, and this angle is 90 degree. So that means E naught is equal to V B naught. So V is equal to E naught by B naught. So we got the velocity. So this is incorrect, this is incorrect, this or this can be correct. E naught by B naught is the velocity. After this, the velocity V is gained and then electric field is switched off. So in the presence of perpendicular magnetic field, the charge will take a circular path. So its centripetal force M V naught square by R will be given by this magnetostatics force Q V B naught. Okay. Now we have to calculate charge by mass ratio. So Q by M will be equal to, so this cancel this. Q by M will be equal to V naught by R B naught, and value of V naught is E naught by B naught. So it will be equal to E naught by B naught square into R. Okay, so this option 3 is correct. So this was very straightforward question. I think in class 12th also we discussed this much. The motion of charged particle in electric and magnetic field simply based on Lorentz force and also some concept of centripetal force. Thank you.